All right, welcome to Lab 5 and 6. We're now going to be looking a bit at layers of the atmosphere. And the goal of this, again, is just to get you more attuned with layers of the atmosphere, have you have a hands-on experience with this phenomenon, and all those other things. So we start out with just sort of a little bit of a reading assignment here. Really nicely put together. I cannot claim to have put this together myself, but it does a very comprehensive version. You can actually just click through all this. Then we have two surveys, and the purpose of these is, again, you don't have to get these questions right. This is where to help you gauge how well you're learning things. It's nice, it's automated, so it's one of those things where hopefully, if it's done right, you're getting fairly quick feedback, and you kind of know what you're doing. In fact, we have two of those because I like to sort of also not only sort of like think of your knowledge, but also what things have you experienced. Because what's wonderful about working at our institutions, we have people coming from a wide number of places and having many interesting experiences. So, all right, so those are the sort of basic nuts and bolts. Let's now go to the now we're going to be revisiting our topographic maps. You might notice we're doing a little bit of topographic maps every week. In case you're wondering why I did the eyebrows there, it was kind of like one of these epiphanies of something I should do for the class, which is probably for that other class, start doing topographic maps every week, starting after the midterm, so that gives you about a month of lead time to figure out how to do that. Okay, got it. So we're going to pause the share here. So anyway, we're gonna first start with the activist. There's two parts to this first part of the assignment, and apologies for how many things that's been broken up into. It's sort of a, yeah. You have 2 weeks to do this, so we're gonna do this. So let's first take a look at here, and then let's fire up both these maps. I have like 3 copies of this one. All right. Yeah. No. All right. All right. Now I've got the lab right up here. This is lab exercise 4. We are looking at here. And so first bit here is we're looking at a number of things. We're looking at stuff on the lab itself. We are also looking at various topographic maps. So what you're essentially doing for this first page, these general questions, is you're going to be going down to page 8 of this lab to look at the diagram there. And you're going to be using a diagram to answer the questions on page 1. This is also why this lab looks really, really long. It's and in fact, you're probably also going to want to look at page 9. And so you'll see here is a really interesting graph of temperature versus altitude. And you can see the various layers of our atmosphere in this. You can also see a makeup of the position of the atmosphere. And so you're using this on page 9. So that's it. And basically all these answers can be basically looked up on that page. Cool. Now we're going to look a little bit more at temperatures now. And again, page 2 can also be answered by looking at page 9. Now it's time to do some something a little bit more mathematical. Once you get to page 3, now we're going beyond just looking things up. Now we're trying to look at some local phenomenon. Oh. And apologies, this was developed at Quebec College. Yes. So you're going to go down to page probably 11 here. So for this part here, you're now going to look at air pressure at and this is just simply going to the back page of the lab here, going to page apologies, I have to go so far down, but we're trying to cover a lot. Boom, here you go. And so you'll notice, by the way, that yeah, there's a small problem. So if you're looking at something like Mount Everest, which is about 8 kilometers above sea level, yes, the typical air pressure for Mount Everest is well documented. Cool. But, and if you look at Cuyamaca, which is approximately 2 kilometers above sea level, yep, nice and easy peasy, lemon squeezy, easy to look up. But then when you start looking up some of the other things like Cuyamaca College, which is at 0.15 kilometers, you don't have anything. This is where one is learning the skill of interpolating. Ah, yes. Interpolating is a powerful tool for basically figuring out numbers that are between points. Measuring the value between more well-documented points. And it's a powerful tool in a lot of what we do here. So you can kind of do this the quick and dirty way. It's just like, oh, it's 0.15 is closer to 0 kilometers than it is to 1/2 a kilometer. But let's do this a little bit better. I'm going to walk you through this. So let's see. So we have 95461 and 101325. So there we go. So I'm just going to jot some notes here. 3, 0. There he goes. Jotting some numbers down here. 9, 6, 4 at 0.5. Okay, and what we want here is we clearly can see that, yes, 0.15 is closer to 0 than it is to 0.5. but we'd like to do something a little bit better. So what we're going to do here is first we're going to take the difference between this, so 1013 minus we're just going to assume that this is a linear relationship because or that's going to give us some 49. Okay, hey, this is looking pretty good. So now what we need to do here is we're going to take 49 and this difference here, and from it, subtract the, do a little interpolation, multiply it by 0.15, 5 over 50, 0.5, or 0.50. And what that's going to give you is it's going to come out to about 15, or a little bit less than 15. Here, let's do the actual calculation on an actual calculator. I'm going to do that on my personal calculator. $14.7. So what you're simply going to do here is taking 14.7 from minus this, and you're going to be getting about 998.3 millibars. So now you see me do that. I'm going to assume you know how to do that for Julian, but if it gets to be difficult, let me know. And you can see there's actually a couple other places where you might have to do a little bit of interpolation as well. So there we go. So then what you want to do is look at what's happening with this table here. So going to be looking at where is the atmospheric pressure, about half that at sea level. And yes, you'll notice that it's definitely not halfway between the surface and the sea level and the top of the atmosphere. It's going to be quite a bit closer to one or the other of those. And I'll give you a moment to think about that. But if you need help, I will offer it later. All right, that's how we're going to do part 1.